Now I should have done that before because now it's reconnecting. Something is wrong with the internet everywhere to this morning. 3x equals 6. The question was, what is the domain, not domain, the slope. And I think I said that before, that students just like to write. Okay. Oh yeah, let me do that before too, before I get into dosary again. And thanks for reminding me. Okay. Let's hope we turned everything on. It's recording. Yes. One more time. 3x equals 6. The question similar to that was, what is the slope? And students divide by 3 and you get x equals 2. And if you ask what the slope is, then you write 2. The slope is what? Undefined. Undefined. Yes, so be careful about that. Another problem that was on the test real quick, and then we get into 3.1 was, and I told you about that one too, was a parabola. Let's say this point is 7. I'm just so making this up. What is the, first of all, turn the light down a little bit. Is this a function, yes or no? Yeah. How do we test for a function? Vertical line test, and if we see it's crossing once, then it is a function. So the answer here is yes. So we're sharing screen. I hope everybody can see anything. What is the domain? The domain of any parabola, doesn't matter if it opens up or down, is negative infinity to infinity. What is the range here? Negative infinity to 7, and 7 is a bracket because it's going through the point. And then you were asked to find f of 0. What is f of 0? What is f of 0? What does that mean anyway? People online, f of 0, what is it? Let me get you on the wrong track a little bit more. This is 4, why not? What's f of 0? Is it 7? It is 7, yes. F of 0, Chloe, that means that x is 0, right? So if x is 0, what is y? Well, the only possible point that you have here is right here. X is 0, you're not going to the left or right, and the answer, f of 0, is 7. Guys, don't get that wrong. And another problem, and we did one in class. Why? Because I knew it was coming. And I don't want to go through the whole spiel, but x squared minus 2x plus 5. And again, I make this up. Something similar is on your test, over x minus 5. And the question is this function constant, linear, quadratic, or neither? Constant, linear, quadratic, or neither? Quadratic. And thank you for saying this because I'm waiting for somebody to say quadratic. That is an answer that I saw, and it is not quadratic because you're only basing it on the numerator. When the x is in the denominator, then it would be neither, because this one is a rational function. A rational function, and again, you didn't need to know that part of the question. You just have to say it's neither because of this part here. So be careful about that. A quadratic, you have if your x squared term is really over 1, if you don't really see the denominator, like 5x squared minus 2x plus 6, that would be a quadratic function. Okay, so be careful about that, but you will see it. I don't know who did it on their test or not. I just wanted to point this out. We're in 3.1 now. 3.1 or chapter 3 is on systems of linear equations. So that the section 1.2 that we kind of skipped over in the beginning of the semester, now we're going to talk about it, because it's actually easier to set up as a system of equations than just one equation. So system of linear equations with two variables. We need to have two or more linear equations. And here's an example. I made that up. X plus 4y equals 9 and 4x minus 2y equals 10. That is a system of linear equations. You see that those linear equations have two variables, and in order for us to solve, to find the solution to the solution is the point where they both intersect. So sometimes that's not the case, but the majority of times our two lines, when we graph them, will intersect in some kind of point, and that point, which consists out of an x and y coordinate, is the ordered pair, and that would be the solution. So if you have two variables, you need to have two equations in order to algebraically calculate x and y. If you have three variables, like x plus y plus z equals 9, guess what? Then you need to have three variables, three equations in order to figure out what x, y, and z is. The amount of variable constitutes how many equations that you need. Now, no worries. In intermediate algebra, you will not learn how to solve systems of linear equation with three variables. That's college algebra. For our purposes right here now, we're only going to look at system of linear equations with two variables, two equations. So that's what chapter 3 is all about. 3.1 is graphing again. So if you like graphing, it's good. If you don't like graphing, you don't like that section. In 3.2 and 3.3, we're going to solve them algebraically by two different methods, word problems, and then we look at some inequalities. Chapter 3 is actually probably the shortest chapter in the book. I think we only cover through four or five sections. Okay, fun stuff. Now, methods for solving systems, maybe I should say for solving systems of linear equations. Is A, by graphing. Graphing, which is in section 3.1. Then B, we're going to look at substitution method. That would be in section 3.2. And C is addition method. That's in section 3.3. So the B and C are the algebraic methods, which are really the exact methods. Graphing, you know, depending on how thick your lines are, and if you move over just one little bit, graphing is not very accurate. So graphing is not the most accurate method, but we're going to graph a couple ones. And then substitution, addition. Another word for addition is elimination. Elimination method, depending on what book you have. So as the words say, substitution, we have to substitute, because in all reality, you can only solve an equation that has one variable, one at a time. So we're going to substitute it and make it one equation with one variable, and the same with addition method. Here we're not substituting, here we're getting rid of one. We're eliminating one of the variables. Okay, so let's, before we graph, -2, 1, hold on. It's basically the same thing you had to do on the test. You have to determine which ordered pair is the solution to the system of equations here. And the system of equation is 3x plus 2y negative 8, y equals 2x minus 18. And there are 2 points that I want you to plug in. And they both, well, separately, of course. And we have to make sure that, like the first point, -2, -1, works or is true for both of the equations. If one equation is a no, then both of them are no. So let's plug it in and see which one works. -2, -1, we're replacing the x with -2, 3 times -2 plus 2y, and we're replacing the y with -1, is that -8. So we do the arithmetic, -6 plus a -2. Guess what? That indeed is a -8, so the top one checks. But we still don't know what the answer is because we have to check both of them. Y equals, in this case, y is -1. So we're going to -1 equals 2 times -2 minus 18. I don't even have to do the arithmetic, but I know that -4 minus 18 is -22, which is not -1. So this one is a no. So if one of them is a no, the question to both of them is no. So -2, -1 is not where they intersect. So that's a no. Both of them have to be true. So 410, and we'll see what happens. X is 4, 3 times 4 plus 2 times -10, 12 plus a -20. 12 plus a -20 is a -8 on the left-hand side, and that obviously is equal to the right-hand side. So again, the first equation works. Let's plug it into the second one. Y is -10. -10 equals 2 times 4 minus 18. So let's see if that's true. 2 times 4 is 8. 8 minus 18 is indeed what? -10. So -10 equals -10. Both equations are true. So which ordered pair is a solution? This one is a yes. And 4 -10 is the only solution here. Any questions? Everybody good? I mean, something we have done already. Like I said, all you need to do is plug them in and see if the left-hand side is equal to the right-hand side. Yes? Oh, I'm giving a talk next month. I'm giving a talk at the end of the month, but that's at the conference. I'm giving a talk with the student math club, and it's about friends. Not friends individually, but the TV show Friends, and statistically proven who the best friend is of the friends. So that should be. Remember that show? Have you ever heard of it? Maybe that was before your time. I don't know. Why does it make always noise here? So anyway, I let you know, and usually what I do is I give a couple bonus points for attending. It will be virtually, strictly on Teams, just like you're already used to it. But I'll let you know what day and time it will be. Okay. Now we're going to get to graphing. So when we graph, there are three possible ways that can happen. And I know you can't see that one, so I'm using a different color now. Let me show you what can happen when you are graphing the two lines. Three things can happen. Not all at the same time. There's only one way it can happen, but three different times, if that makes any sense. X, Y. Okay, so let's say you have your two equations, you graph them, and the first possible case could be looking like so. Here's your first line, you graph it just like we learned before, and then you graph the second line, and you clearly can see that those two lines are intersecting at one point like here, and that would be your solution. So here the lines intersect, and whatever the ordered pair is, that is your solution. So these kind of graphs, they are categorized into different groups, like they're either consistent, inconsistent, they are dependent, independent, and all of this you have to memorize because you're going to be asked on a test. So this first graph is consistent, and consistent or consistency means that there is a solution, be it one or many. So consistent, the graphs are independent. One graph really has nothing to do with the other. They are both different, and there is one solution. And that one solution comes in form of an ordered pair. So how do I remember that? You have, well, I've been doing that for 30 years, but you have to remember CIO. Not CIA, but CIO. Consistent, independent, one solution. I'm going to ask you again in 2 minutes. We're having a little quiz. What does CIO stand for? Okay, I'm telling you, CIO, consistent, independent, one solution. Okay, so that's the first case. Most of the times that will happen, but then you come across, when you graph, you pair, and I always say they don't like each other. So here, the lines are parallel. So when you have parallel lines means this system is inconsistent, independent, because why? Because the lines really have nothing to do with each other, And it is inconsistent because what do you think about the solution? How many solutions do we have here? What's going on when the lines are parallel? Lines are parallel? No, it's the same slope. That's what you're referring to because that's what we had in chapter 2. Indeed, it is the same slope, but Jordan says it on line. There is no solution. Solution means what do they have in common? Well, the orange, they have this one point of intersection in common. The blue ones, nothing. They go separate ways. So the first ones, I always say they shake hands. They're intersecting. One has nothing to do with the other. The second one is they decide to go separate ways. There is no solution. And the third one, now the third one is, I always say they like each other too much because they are on top of each other. But what it means is we only have one graph. Even so, there are two equations, but the graphs are identical. And when the graphs are identical in geography, I almost wanted to say, I can't even say the word right now, in geometry. Oh, geography is on my mind. In geometry, that means the lines are coinciding. The lines coincide. So we have intersecting lines, we have parallel lines, and we have coinciding lines. And in this case, the lines are consistent. And this is the only time when the lines are dependent because they are the same. And when the lines are consistent and dependent, then our solution is all real numbers. Infinitely many solutions is what the book says. And you have that on page 195. Infinitely many solutions. I usually say, because there's a reason for it, not that I can't spell infinitely, but it's many solutions, infinitely many solutions. All real numbers is a solution. And how do we remember that? With a CDM. CDM actually stands for something. C stands for can, D is do, and M is math. Yes, you can do the math. CDM, consistent, dependent, many solutions. And I got so excited about the CDM that I forgot the IINS. IINS means inconsistent, independent, no solution. Okay. What does IINS stand for? What? Yes, and NS, what does that mean? No solution. IINS, no solution. Independent, inconsistent, no solution. You have to remember that. You're being asked on quizzes, tests, and whatnot. What is CIO?
Consistent, independent. One solution.
What is IINS?
Inconsistent.
What is can do math?
Consistent, dependent, many solutions.
What is CIO? Without looking?
Consistent, independent, many solutions.
What is can do math? People, type it in. Come on. What is can do math online? Let me get really close. Oh, scary. Can do math, what does it stand for?
Consistent, dependent, solution.
Okay, let's see online. Consistent, dependent, many solutions. What's IINS? All of you. All of you can answer. What kind of system is that? You can now just abbreviate it, right? And even on a test, you can just say CIO because I know what it means. CIO. Okay. Which system do we have here? We have a CDM. We can do the math. Yes. And if we had two lines, what do we have? I, sir, and S. No solution. I'm going to ask you again in 2 minutes. Okay, let's take a look at some problems in the book. Identify the number of solutions and tell me what kind of system do we have going here. Page 200, number 9. What is that? What kind of system? Nick, do you want to say something?
No.
You're stretching. Oh, yeah, I should stretch too. That would be a CIO. That is correct. And what is the solution here? The solution would be indeed -1, 2. That's your ordered pair. Number 10, what do we have going here? CIO again. And the solution is? Right here, the solution would be 3, 3. Yes, and the last one is? I, and S. And with I, and S, we have indeed no solution. Don't you forget it. There you go. Okay, any questions so far? Like I said, I'm going to ask you again in 10 minutes. Oh, how about number 12? Last one? No, not last one. 13. So what's 12 again? We just did it. No solution. And that would be I, and S. And 13 is what? We can do the math. I used to say can't do the math, but that was negative, so we changed it to can. We can do the math, and that would be many solutions. If you want to spell out infinitely, go right ahead. Solutions. Here you go. Okay, cool. Now we're actually going to have to graph some. Here's our first problem, number 15. And we're going to graph them this, well, the way I prefer is by solving for y, slope, and y-intercept. If you want to graph it any other way that you prefer better, please do so. As long as we have the same answer, I'm happy. So I'm going to solve for y first, and the first one is y equals -2x minus 3. And for the second one, I have y equals, add the x to both sides, and I'm going to write this first, x plus 3. Let's recap of what we just had a test about. What is the slope for the first equation? -2/1, and the y-intercept is?
3. Or -3.
-3. Rise over run, don't you forget it. And for the second equation, the slope is?
X or
1, not x. 1/1, and the y-intercept is 0, 3. Okay. Let's graph them individually. change color. We have 0, -3. That's right here. And now we're going to go down 2 and over 1. We have a negative slope. Down 2 over 1, or we're going to go up 2 and over 1. We end up right here. Connect the dots. See how I'm already not having a good straight line? So use a ruler or a credit card or whatever is straight. That's the first one. The second one has a slope of 3, and not 3, but a y-intercept of 3 and a slope of 1 over 1, 1 over 1. Oh, look how far off I am. This is a classic example how graphing cannot be all that accurate. What kind of system do I have here? You can clearly see that the lines are intersecting. So what do we got going here? CDM, IINS, or CIO? This is definitely a CIO, and the solution is right here, but if I make it thicker, my point, then I'm guesstimating the point to be -2, 1. -2, 1 is my point, and let me see if I did this correctly by plugging it back into the equations. -4 plus 1 indeed is a -3, and -2 is a 2 plus 1, which is a +3. So yeah, they both check. CIO. Cool. I was a little off, but I made my point really thick. Any questions? You try one. Next one. Number 20. Go ahead. Now remember, f of x means y, so both of these equations are already in the proper form. 1/2 x plus 2, and g of x is 5/2 x minus 2. We don't have to rearrange, you just have to graph. And when you're done graphing, let me know what happens. Type out the system online, people. CIO, IINS, or CDM. Elijah says it's a CIO. If you think it's a CIO, please let me know what is the solution. Solution, anybody? Let me wander off and see if we get any answers. Wait a sec. Right there.
I don't draw straight lines.
Right here. I don't either. So we have to draw straight lines. Here you go. You can put straight lines. What is it? Click on my free. You fix it? No? You have the iPad charger? You have the iPad? Oh, I don't know. I didn't go anywhere, so I don't know what I just threw it away. Sometimes I do stuff like that. Now I lost my iPad. Here we go. Okay, so people online, what do we see? We see a 2, 3. I have no idea. Let's figure it out. First one is 0, 2 with a slope of, come on guys, wake up. Okay. And the second one has a y-intercept of 0, -2. I'm just asking people here. And m is 5/2. Okay, 0, 2 right here, and then we're gonna go up 1 over 2. And maybe if you didn't understand the graphing for the last test, maybe you understand it now. The more you practice, the more you know. Isn't that the commercial? The more you know. Okay, go away. I get all these notifications. The more you know. There was something I was reading. I'm following various math Twitter feeds. There was something really cool. Now I forgot. It must have been not too cool if I can't remember what was. I wanted to show it to you guys. Second one, 0, -2 right here, and we're gonna go up 5. 1, 2, 3, 4, 5. Oh, what did I just do? Can't count. 1, 2, 3, 4, 5, and over 2. Oh, look at that. They definitely intersect at the same point, which is kind of nice. And we connect the dots like so. We do have a CIO, and that CIO point is 2, 3. Beautiful. There you go. I like it. Next. Yes, no? Guys, you awake? Yeah. Okay, graph this one. Number 22. 22 in the book looks like so. This thing, maybe I left my charger here, but I didn't charge it. Looking in the car, I was cleaning the car, I probably threw the charger away. 1, 2, 3, 4, 5. And the new iPads is not like the old chargers, so I have so many old chargers at home. I have to go get a spare one. You know what? I think I know now where I left it. I teach in New Smyrna Thursday evenings. That's probably where I left my charger. Yes. Okay, well, there it is. Let's look at the first one. I want to solve it for y. 2y is -3x plus 6, and I divide by 2. Y is equal -3/2 plus 3. The y-intercept is 0, 3, and m is -3/2. So let's do this one first. 3, and we're going to go down 3 over 2. And we end up right here. Down 3 over 2. Oh. There you go. Much better. Y equals -3. What kind of line is that? Yes. How do I draw that line? Y equals horizontal on -3. All right. I thought that's what you meant. That's what you did mean. Okay. We have a CIO business going on here, that's for sure. I also know one of the ordered pairs -3 because that's y. What about x? It looks like on mine it's 4. It's a horizontal line, right, Elijah? Thank you. It looks like 4, so we're going to go with 4, but I'm going to check it. I check it in the top equation. 3 times 4 plus 2 times -3 is indeed 12 minus 6, which is 6. Yes, here you go. We have CIO business. Cool. There it is. Okay, that's really the gist of 3.1. Let's see what else. I don't want to graph this anymore. I think we have an idea. Let's do some true or false in the book. I took a picture of true or false. 33. True or false, people? Tell me. 33. A consistent system is a system that always has a unique solution, and by unique you mean one solution. A consistent system is a system that always has a unique solution. True or false? Okay, let's have a decision. Some people here say true, some people say false. So who is for true? Hands up. I heard true. No, you're not for true anymore? Who's for false? And the rest? Who's for I don't care? Don't do it. What was the question? I forgot. A consistent system. A consistent system. So that could be CIO or can do math. And because can do math has infinitely many solutions, that makes this a false statement. It does. Wait, what did you say? I don't know what I said. Meant unique unique means one solution. One solution. A unique solution means one solution. And that would be false because it can also have many solutions. Oops, that's a false. So, number 35. If two lines coincide, the equations are dependent. True or false? Come on, guys, go. True or false? I'm gonna fall down. That would be fun. You would be laughing, but I wouldn't be. 35, sorry. If two lines coincide, the equations are dependent. True or false?
I'm gonna say false. False, because if the lines are colliding, could that?
No, not colliding. Coincide. They coincide. They are not colliding, which, I mean, you can think about that the way you want to. Colliding and coinciding, is it the same?
No.
No. So Tony Marie says true, Danielle said false, right? Oh, you said true, right. She said false. Right. If two lines coincide, the equations are dependent. Jordan has an opinion, and so does Chloe. The answer is, say loud. True. Two lines coincide. CDM. Consistent, dependent, many solutions. Okay, 34. Dependent equations form a system that has no solution. 34. Dependent equations form a system that has no solution. Oh, I was looking to 38. Oh, that's a good question. Okay, 34. True or false? What are we talking about? Dependent equations form a system that has no solution. True or false?
False.
Guys, are you awake? True or false?
Can do math.
We can do the math. Dependent equations form a system that has no solution, which Chloe says is false, and the people here did too. So it is false indeed. And 36, if two lines are parallel, the equations are independent. True or false? True too. IINS, independent, inconsistent. That is true. Yes, okay, here it comes, my favorite problem. 38, write a system of equations with the solution 2, -6. You have the solution here given. And you have to come up with a system of equation that has this point as solution. Here's 2, let's say -6 is here, and we are right here. What is a system of equations that has this point as solution? That problem has been on test before. I'm telling you, it's the easiest problem of them all.
We just do like x equals 2 and y equals -6.
It's one, I mean, there are many other ones, but if you don't want to sit there for half an hour and figure this out, the easiest of them all solutions for this ordered pair is x equals 2 and y equals -6. That, bless you, that, believe it or not, is a system of equations. And that is very possible answers. So y equals 6 like so, x equals 2 like so, and you see they intersect right here. Beautiful, yeah. Now you know. The more you know, now you know. 2 weeks from now, you're going to be asked again. Okay. And that's all about 3.1. And now, what time is it? Oh, we can do 3.2 and 3.3 all today. Are you ready? Substitution method. I'm ready. Let me 5x plus 11. Y equals 5x plus 11. Let me do this problem without any instructions. So they want you to solve it substitution method. Substitution method means that you have to substitute one equation into the other. And you also have to look for one of the equations has to start with y equals or x equals. You have to isolate one of the variables. So if that's not the case, you may have to rearrange some stuff. In this case, in this example, I think it's out of the book somewhere, this is already done. The second equation says y equals 5x plus 11. So we don't need to do any rearranging here. What we have to do is substituting. And what are we substituting? In the second equation, we know what y is. Y is 5x plus 11. So why don't we use that 5x plus 11 and substitute it into the first equation for y? Because remember, we can only solve an equation that has one variable. So that brings us to the equation 4x plus 12y, and y is now 5x plus 11, so I replace the y with 5x plus 11, and that is equal, continuing with the first equation, that's equal to 4. So what I did was I replaced the y with 5x plus 11. And now you can clearly see you have an equation with one variable. And that one needs to be solved, just like we have done before. So 4x plus distribute, 12 times 5 is 60x, 12 times 11, 132 equals 4. You distribute. Combine like terms, 64x, and let's just subtract the 132. 64x equals negative 128. You divide by 64. X is equal to negative 2. Beautiful. I gave this test once, and I had a student who only answered one of the variables. Like x equals negative 2, and then he stopped and went on to the next problem. I think he had a 50 on the test because he had everything right. No, he didn't. He forgot the other coordinate. You have to solve for both of them, x and y. If there is an x, there has to be a y. I mean, sometimes the lines are parallel, then we have a whole different situation going there. But if you get a value for one variable, there has to be one for the other variable. So what do we do with this knowledge? We take the negative x equals negative 2, and we substitute it again into the second equation to find y. So y equals 5 times negative 2 plus 11, negative 10 plus 11, y is equal to 1. And to make it look pretty, the solution is, we write it as an ordered pair. The solution is negative 2 comma 1. Done you are, off you go. Not yet. The solution is 2, negative 1. What kind of system is that? This would be considered, let's see what the people online say. This would be considered a Jordan's typing, or not. It's weird how sometimes you type and then nothing's happening. See, Chloe says it's CIO. Whenever, yeah, it's weird how names pop up. Whenever you have an ordered pair as a solution, that means that's your point of intersection. That's always a CIO.
Ordered pairs equal CIO.
Mm-hmm. Consistent, independent, one solution. That is your point of intersection. An ordered pair always. We're on a roll today. And it's only 12, so we can do another problem. What do you think? I think so. Paul McCartney or Elton John? Back to that. Yeah. Bless you. Elton John. Which movie did you like better? The Elton John movie or the Queen Freddie Mercury movie?
Bohemian Rhapsody.
Did you, yeah, like, thank you. I didn't.
It's so good.
I liked the Elton John movie better.
I watched the Elton John movie.
Yeah, I
I
don't
didn't
know.
watch the Elton John movie, so I guess my opinion is.
Oh,
biased.
yeah, well, yeah. I liked the Elton John movie better. I don't know why. Maybe because Richard Madden was in it. Yeah, I think that was it. Yep. Okay. That's the first, okay, back to math. Does the first value you find always go back in the equation you found it with, or does it matter? It doesn't no, it makes sense. It makes perfect sense. Jordan is asking, should we always plug in the value, the first one, into the equation that we found it with? Not necessarily, it doesn't matter, but we are mathematicians and we want to pick the easiest way. And the easiest way to plug in the first value, you plug it always into the equation that says y equals or x equals, but it does not matter. So with that note, let's do this one problem and then we go home. Now here I wrote the instructions. I wrote them down so we can follow them. The first step would be to isolate one of the variables. So it has to be y equals or x equals. Now be smart about it. You always want to look at your equation that where y or x don't have a number in front of it. So in this case, it doesn't matter if we should pick the first one or the second one, but there's one that's probably an easier step. It doesn't matter. Which one you want to rearrange? The first or the second one? The first one. I go with the first one as well. 3x plus y equals 0. So we want to solve this one for y. And we're just going to go ahead and subtract 3x from both sides. Why did I just write y? I have no idea. So that means our equation is y equals negative 3x. It's less to work with, so it makes it easier, the first one. But it doesn't matter. So we've done step one. We isolated one of the equations for y in this case. But some of you could have rearranged the second equation and isolated the x. It makes no difference as long as you're doing it right and are consistent. Now we're going to go ahead and substitute this equation from step one into the other equation that we haven't touched. So the other equation is x minus 2 times negative 3x equals 12. Here you go. Replace the y with negative 3x. And then we do the arithmetics. That would be a plus 6x equals 12. What? Did I copy that right? Nobody knows. I copied that wrong because that is not, now we're doing it with the values we have. I don't think that was a 0. I think that was an 8. But we love fractions, so that's not going to deter us. We're going to divide by 7. So x is 12 over 7. Based on this being a 0, but I don't think it was a 0 originally. But you can get fraction order pairs. So now we're going to go ahead. So we are step 3, we solved the equation. Step 4, substitute answer from step 3 into the equation from step 1. Well, step 1 was right here. So we're going to substitute y equals negative 3 times 12 over 7. And let me make this negative 3 as 3 over 1. Substitute, we're going to, how do you multiply fractions? What does that mean?
Straight across.
Straight across. Okay, then tell me what the answer is.
36 inches.
I said G, but you are correct. Negative 3 times 12 is negative 36. 1 times 7 is 7. There's nothing we can reduce. So the ordered pair here, where they intersect, is 12 sevenths, comma, negative 36 over 7. Perfectly fine answer with the numbers that I copied wrong. There you go. And you can always check. Maybe that should be my 6 point. Check your answer, but I don't want to check this one right now. We're going to stop here and continue with substitution method and addition method on Wednesday. See you then. Bye, guys. Any questions? Guys online? No? Okay. Okay, Valentina, bye. Bye, Chloe. No questions. Cool. Stop recording.